we are now in a totally new section in atomic tests, which is our next section. And as Borat says here, and probably as you could figure out from where we were going, was that these are not the most efficient, ideal tests for our testing purposes. As somebody said, that they are acceptance tests and they're through the UI, which is great, but there's different levels of greatness, right? We can do something one way, or we can do something more efficiently that makes our tests faster and more stable. And so that's why we do automated atomic tests. Here's a little description of what an automated atomic test is. It's basically ensuring that we are testing only a single feature through our tests. This is whether it's a unit test, an integration test, or an end-to-end test, an acceptance test. All of this applies kind of the same. It's much harder at the acceptance test level. However, it is possible. It's possible to just focus on a single feature and ensure that that feature is working, while basically we can mock or remove or isolate everything else that isn't relevant. This is like a really deep topic. There's so much to talk about in terms of technology, but we're gonna do one atomic test here, and I hope that it will kind of open up your eyes and you'll be able to see some possibilities that we can do with web applications. There's a lot more. I put a read more link there. I've written a massive blog post about this, doing different kind of examples. So the steps to creating an atomic test is find the functionality that we want to test, isolate or mock or fake all irrelevant actions around that functionality. A lot of times that involves setting stuff up and tearing stuff down. And then somewhere in the middle is the thing that we actually want to test. And so that's the part that we're testing the relevant feature through the UI. And so which of our tests was not atomic? Let's come over here and take a look. So actually, let's come over here and take a look at the code. Let me hide this. So the test that is not atomic is this user can check out. Why is this test not atomic? Well, because it's testing multiple features. Our very first feature that we tested was that our application renders, right? We ran this test and we already know that our application is up and working and the login page is there. In fact, not only are we ensuring that our login page is here, we're also even ensuring that our login page is there. So we're checking the login page 2 times. We also already tested the login in this test. We know it works. However, we are repeating the entire process here. Again, going through the login and testing that. And even there are stuff like adding a product to a cart. That is relevant to our test case that a user can check out. However, we don't necessarily need to do all of these actions through the user interface. Why do we want to decrease the amount of interactions we have with the user interface? Because number one, it's slow, right? All of these commands touching the user interface are web requests, and web requests have to travel over the internet and making everything slow. But second, and probably the most annoying part, is it makes everything less stable. The more web requests and Selenium commands we have, the less stable our tests actually become. We did a study like 1 or 2 years ago where we analyzed 2 billion tests, and we found the pattern that I kind of have experienced my whole career, which is that the longer the test is, the more likely it is to fail. In fact, the test that was 7 minutes long was 3 times as likely to fail as a test that was 2 minutes long. Again, it just falls back to that entire idea that more Selenium commands, more flakiness in the automation. It's just more things can go wrong. And so this is there, but it's unnecessary. The only part that we actually really care about is having a product in a cart and making sure that a user can successfully check out. So really it's this part that was, this part that was really only relevant to our test, because all the other stuff is just preconditions. And so let's look at our application and actually how it works under the hood. So let me come here and log out. Log out. And we'll look at the dev console. Let's look at our application. Let me see. Okay, nothing there. Sorry, I'm just checking, make sure there's nothing saved, okay? So that there's no trickery going on. This is saved. We're gonna get rid of this. Okay, so here's how our application works under the hood. And a lot of applications work this way. Not all applications work this way, so it's important to determine how your application works at your environment. But as I said, a lot of them work this way, and then others work in kind of different ways. So when we log in, let's take a look at what happens. Our application uses a cookie mechanism, which is super common across the web for authentication. So we just logged in. If we come down here to our cookies, we can see that we have a cookie set with the session username and then the value there for our application. And so once you log in, a cookie was dropped. And so this is something that we can actually do without interacting with any web elements in the browser. We can do this with all types of logins. We can do this with logins that drop a cookie. We can do this with logins that hit a web API and then get a token back. We can replicate that as well. We can do this with applications that hit a web API and get a cookie back that gets dropped. There's multiple types of login mechanisms, and most of them can easily be done without touching the user interface. Okay, we got a cookie. Now, what about adding an item to a cart? If we click an item, add an item to a cart, and then we look at our local storage, we can see that now we have this key here called cart contents that has this value, right? So what happens if, for example, we do document.local store, actually it's local storage. Local storage dot set item and do something like this, right? But instead of item 4, we put in, let's say, item 1. We add that here. We go look at our application. We see that now we have 2 items in our application. And if we refresh it, the UI will update to 2 items. So again, not touching the user interface, I'm able to manipulate how many items there are in a cart. We can do the same thing for the logging in part. So let me show you that. Let me reset app state and log out. So just to show you, nobody's cheating. Here's a cookie, no session username cookie, right? If we come to the console and do document.cookie, cookie, and do something like this, you can see that if we set this cookie with this session username and then pass in the username, let's do that and hit enter. And then let's take a look at our application and the cookies. You now see that we have this session username available. And if we wanted to visit a page behind the login, such as inventory HTML, we can do that because we are logged in. While if we weren't logged in, here, let me log out, you can see the cookie disappeared. And then I try to do inventory/HTML, it's not allowed because we're not logged in. And so that's how we can bypass logins, but also we can inject items into a cart without interacting with the UI. And of course, we can replicate all of this, in our case with Selenium, but in other cases, if there's a web request that needs to be performed, you can use the appropriate web request library to perform that operation. And usually those are like the 2 major cases that allow you to bypass that. So with all of that said, let's make our test atomic. I just showed you how we are able to basically log in without touching the UI. And we are also able to add an item to a cart without touching the UI. And so our atomic test, if it was really atomic, the way it would look would be like this. We would inject a cookie into our application, right? So now that we got the cookie. And so if we're focused on a user can check out test, what is the only place that is relevant? That is, what was the checkout step 1 page, right? So now we can navigate to that page. I didn't log in. I didn't add an item to a cart yet. I simply dropped a cookie, navigated to checkout step 1. And now what's the only other precondition that's missing for a user to be able to check out? That's having an item to a cart. Well, so then now we can replicate that by doing something like this. Doesn't matter whether there's 1 item or 2 items, right? That's not relevant here. What's relevant is having that item. We are dropping it in the cart using local storage. We're refreshing. We now have that item in a cart. And now at this point, Selenium can step in and ensure that a user can successfully check out without retesting all the functionality that we've tested before and know is already working. And so your exercise is to go to end-to-end-test.java and follow instructions in this test method and create an atomic test. And then at the end, of course, you'll run all the tests and make sure that it works. So you're navigating here. You'll remove the ignore because now we care about this test. Oh, you're going to open it up and you're going to follow the instructions in here to make it work. And then at the end, you're going to run a Maven test and run all the end-to-end tests, make sure everything works. There's a little hint to everybody. We've done this test before, right above. So you do have a lot of code there. However, you're going to be replacing a lot of those UI interactions with JavaScript executor interactions and a cookie object from Selenium, right? The cookie object will allow us to log in. The JavaScript executor will allow us to inject the JavaScript exactly as I showed you in the browser, but using Selenium. So that's really what it is. And then once you're logged in with the cookie, once you have an object in your cart, the next thing is just bypass all the pages that are irrelevant and get to the starting point of the feature you want to test. One question I've gotten a lot in the past about this, I actually did an entire workshop, well, not an entire, but a huge portion of a workshop around login testing, is this applicable to all applications? And kind of, as I mentioned before, no, not all applications log in like this. Many applications log in with cookies. For example, if you look at Amazon, when you log in and then you go to application and check the cookies, you'll see Amazon drops cookies in your browser. So your application may do it like that. There are other applications that have an authentication API. So it's a web request that's performed. And then when the web request is performed, they get back a token. It could be like a JSON web token. A lot of applications written in JavaScript, they'll get back a JSON web token. And then that token is used throughout the user session to be able to make sure that the user can access those appropriate pages. So in that case, instead of dropping a cookie, you would just perform a web request, like using in Java, what's a Java API client? Rest Assured, I think. You could use like Rest Assured, perform that web request, get back your token, and then use that token as part of your session to log in. There are other applications that have like Okta authentication. There are other applications that can do like, there are a number, actually, I'll show you all I did. It's in JavaScript, the other workshop that I did, but there's a number of good lessons from it that you can take a look. It's here in this logging testing section. It's a number of different types. So we tested HTML forms, log in with the HTML forms, log in using JSON web token. I showed you already how to do it with a cookie. There are a number of, here's the other numerous ways that we can authenticate, right? SSO, XHR, CSRF, basic auth. There's documentation kind of there if you want to explore that for yourself in the future. Someone asked a wonderful question. Anonymous attendee said, in the test, do you think it's fine to have code related with driver cookies, considering we have page objects abstraction layer? That is such a great question. Let me, I don't want to reveal the code. Let me see if I put that in here. I swear I talked about that. I guess I didn't talk about that. That is a great question. And so, no, I don't think it's okay to expose that in the test. The only reason I did it was to simplify this for everybody so that they can see the actual code, right? Instead of having to navigate to a method and see how the method works. I put it in directly in the code so that everybody can see, but you would want to abstract this out, right? So for example, this method right here, executing script of setting an item of cart contents, right? You want to reuse that probably in your application all the time. So you don't want it in just a single test. You want to probably put that in a app object. A lot of times what I end up doing is creating a application level object. And that application level object houses page objects. So you would have something like app.loginpage.login, right? And so then through that way, you can do app.setState. And so then when you do set state, you can do like set item count, or you can do app.login with cookie. You can do it. That's one way to do it, right? Think of your application controlling all of that. The other way to do it is through a browser object. Think as your browser controlling the application state. So browser.setCookie, browser.setLocal storage. So I don't know which way I prefer. I've done with the app object in the past, and I liked it, but I think either one of those should be okay. All right, so let's go through the solution. I'm not going to type it out this time because you guys don't need to see me typing. We're going to go to here, end-to-end solutions test, okay, in the solution. And we're going to look at, we're going to start looking at how this test works. I don't want to reveal the entire answer, and hopefully that helps the people that we're not able to finish yet. So code as before, starting out with a login page and visiting. And the only reason I put that here was so that we can perform operations on the browser, because you want a browser up. But and actually our page will not, our application doesn't let us access any other pages until we're logged in, right? So we put that in here, fine. Now is the part where we want to perform less browser operations. So the very first thing we're doing is deleting all cookies to clear the state of the application, and clearing local storage. Next, we're using Selenium's cookie object to drop a cookie, session username and standard user. This is exactly the thing that I showed in the console. We're just replicating, sorry, let me see. In the console here, we are just now replicating with Selenium. This is the JavaScript command to make it possible in the browser. And then Selenium wraps that into a cookie object. And then we are just adding that cookie. Next, because we're now logged in, we don't even, we can just navigate directly to the shopping cart page and visiting. And here I am just checking that the application is in the correct state. To be honest, I'm realizing now we probably don't even need to visit the cart to check that there are no items in there. I guess we could. I think this is good. Let me know if you disagree. I'm checking the state of the application before, right? That it has 0 stuff. And then we are using the JavaScript executor to set the cart contents, exactly as we've been doing in the terminal. Refreshing the browser, which is how the UI gets re-rendered. And then we are ensuring that one item was added here. And now that I think about it, I probably wouldn't even do this part. I think I only did it for exemplary purposes here, because if we do this, add an item to a cart through JavaScript, and we check that there's only one item in there, that does exactly that. Why do we even need to check that there were 0 items before? So I'm actually going to even comment that out because I think it's unnecessary. Oh, but we do need a cart. So we'll just do this. Let's see if I don't break anything live. There you go. Hopefully anyone getting closer to finishing this up. Any more yes answers to the poll? And then I'll continue here, hoping everybody's wrapping up. Final step is just navigating to the checkout step 1 page. The checkout step 1 page was where our functionality really starts, right? Right here. And what we could have done really is, let me see here, what would have been better. Oh, you know what, I messed it up. We did need to visit this page to check. Actually, we don't even need to visit this page. Sorry, I messed things up for everybody. That's because I'm like thinking live here. You know what probably would have been better is if I just did this. I did this part up here. Actually, let me cut this out. If I did this, visited step 1 page, drop the item in the cart, ensure that the item is in there, and now proceed with the checkout process. Makes sense? It's by removing really these 3 lines of code altogether. That probably is better. And then just entering personal details and checking out. This is the feature that we really care about. Let's run this and see how that looks. I could have messed stuff up. Let me know if you see I made an error. I can only focus on like one thing, so it's really hard for me to talk and code at the same time. And sometimes I make mistakes. My test passed, which is amazing. So that's a good sign. So user can check out Atomic. So one thing that's kind of interesting to note here right away is you can see already this test was faster. That's because we're bypassing all the extra Selenium commands that we needed to perform. So what is that? I don't even know, can't calculate that percentage, but it's a good amount faster, right? Like, I don't know how many percent, but good amount faster. And that's just a tiny little test. Imagine this applied to an entire test suite, to all of the tests. So you have the one login test that actually performs the UI login, and then all your other tests don't log in and set up state in a faster way. I've actually worked with customers where using this mechanism plus parallelism, we reduced the test suite size by 97%. Like the amount of time it took one test, the entire suite to run was less than the amount of time it used to take one of their tests to run. So that's how powerful this thing can be. So here's what that test looks like. Executed. I should have probably been slower. So here, so here we are. You'll see no typing or interactions there, obviously, because we're just dropping a cookie. So, and you can see automatically we can already access this page. And now we're really where we want to be. The only other thing we want to do is set another precondition of dropping an item in a cart. Boom, there it is. We're not even on the cart page, but we're able to simulate that behavior. And now that's where Selenium comes in and starts executing. And you can see here, these are, by the way, all of the commands that Selenium executes. I find a lot of us never having done execution in a Cloud Grid environment, which is actually, I think, mandatory nowadays to be able to run and scale fast enough with our test automation. Every single Selenium command is a web request. So you can see here, that's what happens. So the more of these that we have, that's how our tests become really slow, but also unstable. And so this atomic testing kind of thing, that's the whole idea behind it. We're eliminating as many UI interactions as we can, isolating the behavior that we want, and then only using the UI there. And so, for example, here's how a cookie is set, right? You can see a web request for a cookie. Let's see here, what else is important? Here's our JavaScript cart contents command. You can also see how fast they are, right? So for example, this JavaScript command is really quick. 0.1 second, oh no, yeah, 0.1 second, half a second from here to here. Versus like some Selenium commands like this one, 0.25 seconds. I guess not too bad. Cool. Let's see where we at. Questions or concerns about this process? I usually get a lot of questions about this because it's kind of new to a lot of us. Let me see. I see some in the Q&A. Hello, Wen. I'm going to answer some questions here. Chandra asks, when we have a test, which we can go all the way to checkout, then why can't we delete the previous test if we think it's duplicate code? This way, we are still writing a test. A normal end user would browse our site rather than playing around with cooking the test. Test is faster, maybe by 64% using it. Thanks, Chandra, for doing the calculation. 64% faster. Great. Chandra, I didn't fully understand. So you're saying when we have test code, which will go all the way to checkout, then why can't we delete the previous test? Oh, are you saying that basically, all right, so you're saying that instead of doing this, why can't we just do this? A user can check out, which tests all of the features, right? So going from the beginning to the end and testing things, everything at once. Well, that is a really bad idea for numerous reasons. Number one, this test is really fast, right? My application is really small. If you have a big application and you need to go through the entire application and test everything, that might take dozens of minutes, maybe even hours, right? And who can even can you even guarantee that you've tested all of the features? I don't know. That's really hard, number one. Number two, if along the way your test fails on adding an item to a cart, or not able to locate an element for any reason, or you weren't able to synchronize correctly, now your entire test fails and all of the features afterwards don't get tested and you have no idea at the state of their quality. And then the last piece that is bad about end-to-end, long end-to-end tests is that you're not going to be able to run in parallel. And so instead of running horizontally, meaning that where we were actually going to talk about this towards the end, we were going to make all of our tests run in parallel. You're going to see an insane speed performance improvement from running our tests in parallel and horizontally instead of having one test that is vertical, because the longer your test becomes, your entire test suite runtime will be as slow as your slowest test. So if you have a test that's 45 minutes long, your entire test suite will never run faster than 45 minutes. However, if we have 45 one-minute tests, we can run all of those in parallel and our entire test suite will run in a single minute, even though it's 45 tests. And so the power of that is insane. You'll get a little preview of the parallelization at the end when we implement parallelization. But those are the reasons why we never ever want to have an end-to-end test that navigates from screen to screen to screen and does all the testing at once. Let me know if something doesn't make sense. Cool. Yeah, Chandra, amazing question. Thank you so much for asking it again. I hope that when we get to the parallelization part, you'll see the massive win that we get from having a ton of tiny tests running in parallel. And then if not, let me know if you still don't agree with me. So someone says, what your look on UI API tests together in one framework for doing it similar? Yeah, it's an amazing idea. I strongly encourage it, anonymous attendee, to combine UI and API testing. With the UI and API testing, your tests become way faster and way more stable. In fact, when I was talking about helping a customer decrease their test suite runtime by 97%, that was a combination. That was thanks to this atomic tests pattern. We had a bunch of little tests doing UI testing, a bunch doing API testing, and all of them running in parallel. And that was the only way to make that possible. Oh, and by the way, when we decreased 90% to 97%, by 97%, we actually increased their test coverage because it ran on more mobile devices than before. So it was even more test cases, but running in only 3% of the time that they used to. And yeah, it was using that combination. Let's review our test coverage and see what we accomplished with all of these tests. So a login page renders, we continue to do that part. Valid user can log in, everything's okay. User can check out with the product. We did that. Selenium Sauce Labs, I'll add in here cookie injection and JavaScript injection. It's not really, I wouldn't call it, technologies, but let's just add that there just so we keep in mind how we were able to accomplish that. So really now, if this wasn't a workshop and we were really writing a production suite, I would totally just remove this test. I mean, I'd keep the name, but I'd get rid of this test and I would only use this one from this point forward. All right, so next we have to figure out how we are going to ensure that our 3 pages, our login page, products page, and cart page, look as expected on Chrome and on Safari on the most popular resolutions. And we are going to do that in the next section.